Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor. Before we get started, I do have a few things to go over. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenters. We do encourage engagement in the chat. There you will also find useful links. This session is recorded and will be available in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and our speaker today is Jim Bennett, who's a regional cloud advocate. I'll now turn it over to Jim.
Awesome. Thank you very much. Hello, good morning, good afternoon, good evening, wherever you are in the world. Welcome to this stream. If you're just watching Christos, I hope we didn't cut him off mid-bug fix. It looked like he was frantically trying to fix a bug. Ooh, if you may not be getting this on Twitch, we're seeing some weird messages coming through. So if you are watching this on Twitch, apologies if we kicked Christos off at the wrong moment. I'm sure he'll berate me later for it. But welcome everyone. We're here to do a session all about IoT with Azure Sphere. Now, do have to offer some potential apologies. It's springtime. It's the time of year when people's thoughts turn to their garden, and the local gardeners are out in force today. So if you hear a loud, deafening roar, it's a petrol-powered lawnmower or strimmer or leaf blower or whatever else they're doing out there. So apologies for any background noise. So today we're all about developing secure IoT solutions using Azure Sphere. Now, I'm an IoT person. I love my gadgets and gizmos. I mean, literally behind me, I have, I can kind of reach over and just grab any number of IoT boards. I have gadgets and gizmos aplenty. It's almost like the Little Mermaid song was made for me. So I have all these gadgets, and I'm great with getting them connected to the internet, and I'm great with building some fantastic pieces of gear with these. But one thing I'm not so hot on is security. Now, security, it's one of those tenuous issues when it comes to IoT. There is an old joke that the S in IoT stands for security. The joke being there is no S in IoT. So, there's been a lot of issues where IoT devices have not been secure. In fact, if you Google with Bing for IoT hacks, you will get so many hacks listed. There's been a lot of situations where IoT devices have either been the target of a hack or used for a hack. I'm going to quick search here with Bing. What do we get? The Mirai DDoS botnet. This was a distributed denial of service, all launched from IoT devices. So they hacked into IoT devices and then used that to do a distributed denial of service attack. Jeep, car manufacturer. They've been a remotely stop and control Jeeps. There's Wi-Fi heart monitor for babies that's been hacked into. We've had all manner of hacks using kids' toys. Baby monitors, the cameras that you use to check your kid is okay at night. They've been hacked. So hackers have literally been appear at your child and even talk to your child through these cameras. One of my favorite hacks of all was the Atlantic City fish tank hack. So if I could spell, Atlantic City fish tank hack. This was great. And so what happened is criminals used a fish tank to steal data from a casino. So in the fish tank, they had a smart thermostat. This smart thermostat had an open Wi-Fi access point. If you've ever set up consumer IoT devices, you would have used these open access points. You would connect your phone to an open access point on an IoT device and use that to then connect that device to the internet. It's kind of a fairly standard thing to do. Except this thermostat never closed down the public Wi-Fi access point. And so hackers could connect the public access point on the thermostat. From there, hack the device, piggyback onto the internal casino network, and download a whole lot of data. So there's so many of these weird and wacky IoT security scares. In fact, top tip, if you ever want to get an IoT consumer IoT device, just search for any hacks in it. And as soon as you see the hacks, run away scared. Yeah, I'm an IoT person. I love IoT, and certainly there's a lot of consumer IoT devices I will not touch with a barge pole because of all the security issues. So I'm kind of here today to just talk a bit about security with IoT and for me to learn something. So I want to learn with everyone here all about IoT security using some cool bits of hardware. So welcome everybody. John from Leeds. Hello. Welcome. Glad you could join us. As you may notice from my accent, I am British. So I was born and bred in the south coast of the UK, now live in the US. But it's nice to see somebody from home join us. So everyone else in the chat, feel free to say hello, introduce yourself, let me know where you're from, and let me know what you've done with IoT. I'd love to kind of know what you've built with IoT, whether you've done much security, and yeah, just share some cool stuff that you've done. But for today's session, I'm going to be working through one of our Microsoft Learn modules that focuses on Azure Sphere. Now, Azure Sphere is our secure IoT solution, something I've not played with really, so it's something I want to learn about to help me build secure IoT solutions. The best way to learn Microsoft stuff is using stuff on Microsoft Learn. So we've got this whole hands-on module that's been built to help me learn about secure IoT. So you're invited to come along on this journey with me. This is a 2-show series. This module is a 2-hour module. We've got an hour today and an hour this time next week. Ravi's in San Diego. Nice to have you here, Ravi. Thank you for joining us. So it's a 2-hour module, an hour today, an hour next week. And we're just going to see where we get to, have a bit of fun learning together. So everything's here. We've just dropped the link in the chat for you, aka.ms/secure IoT Azure Sphere, if you want to follow along with us. You will need an Azure Sphere board. And Azure Sphere, fantastic piece of kit. A little bit difficult to get at the moment because everything is a little bit difficult to get at the moment. So if you've got one, you can join along with us. If not, if you can get your hands on one, obviously let this learn path be here forever, so you can always come back and work through it yourself later. So John says, I do talks on web application security, build devices using Arduino and Raspberry Pi, and I'm an IoT North meetup. Very interesting, the Sphere. Awesome. Yeah, so there's a lot of great IoT meetups in the UK. There's some fantastic Microsoft MVPs and other folks doing some cool IoT stuff. So it seems like the UK is the cool place for IoT. So a lot of good meetups. There's even one called IoT, T as in the drink. There's a lot of cool meetups that happen around IoT. IoT North, I think I know some folks who've spoken at there. Good meetup. So yeah, great. Yeah, Arduino, Raspberry Pi, great beginner level boards. Kind of interesting to see how secure they could be, whereas Sphere is built for security out of the box. Oh, and John's also from Sussex. Yes, I'm born and bred from Sussex. Chichester was where I was born. So just random facts about being born in Chichester. I met a fellow parent at my daughter's school. I'm part of the school PTSA. Met a fellow parent. She's Argentinian, and she was born in the same hospital as me in Chichester in the UK before she returned to Argentina. So, it's a small world. Lots of people from Sussex or from that area. Cool. So before I way through this, let's actually look at what we need to build with Azure Sphere. So what are the bits we need? We need an Azure Sphere kit. That's IoT. The T in IoT is things, it's the Internet of Things. We need hardware. And so we need an Azure Sphere kit. We need a bit of hardware to work with. We'll look at a couple of those in a minute. We need VS Code installed and the ability to use VS Code. Okay. It's good to install it and know how to do it. Git, use of Git, and a bit of knowledge of Azure Sphere and Azure IoT, but not too much knowledge. We'll pick this knowledge up on the way as we go building. So let's actually look at some Azure Sphere kits. This is an Azure Sphere board from Seed Studios. Just drop this link in the chat. You'll notice out of stock, global supply chains, what they are. Sometimes at the moment, getting microcontrollers is challenging. If anyone's tried to buy a Raspberry Pi, you know what I mean. But this is one of our Azure Sphere kits. This is a basic dev kit, so it doesn't have much in the way of additional hardware. It's got a secure chip on board, little slot in the back for a battery, and that's about it. It's got interfaces, GPIO, UART, I2C, SPI, all that kind of stuff. So you can connect stuff to it. But out of the box, it's just the board. Now, Seed also have the whole Grove ecosystem. So if you want to plug the board into anything else, Seed have a mounting kit you can put it into and plug into their Grove ecosystem. So you can plug in all the extra hardware that you want, LEDs and buttons and temperature sensors and distance sensors and relays and all that kind of stuff. So the kit you can get, the kit to plug into you can get, Sphere board, not so easy to get. So that's one of the Sphere hardware options. Another option is from Avnet. They do a kit that's actually got more stuff built in. So this is a similar idea. It's a Sphere board, but this has got some extra hardware built in. It's got gyroscope, temperature sensor, light sensor. And then it's got connections to plug in OLED screens and all manner of bits and pieces. So it's a little bit more powerful, a few other bits and pieces on there. In fact, let's have a look, see if they've got any in stock. Just drop this link in the chat as well. Ooh, they've got some in stock. So Avnet do have some in stock at the moment, which is great. So a whole lot of great boards. And rather than just look at them on a web page, let's actually look at these actual boards in the flesh, as it were. So let's start with this, the MT3620 mini dev board for Azure Sphere. Pop this one open. And this is the board. So AI Link WT M620 RSC1 Azure Sphere board. So this is the Azure Sphere. Now, out the box, it's got Wi-Fi connectivity. Yeah, you need to connect to something. And in terms of the hardware on here, it's actually got 3 processing cores. It has one powerful core that runs a version of Linux, and that's a non-real-time core, and that handles all the security. And then it's got 2 real-time cores that handle all the microcontroller stuff. So it's kind of like 2 microcontrollers and a small Linux processor running on this board. And that's kind of the way Sphere works. You use the main microprocessor to run your networking code, and then you run your real-time cores to interact with hardware. And there's firewalls in between. So that's kind of part of what makes it secure, is you can't access one core from the other without all the right permissions. It's pretty cool. So that's the Avnet dev kit. To say there's not much on there. Plug a battery in. It's a microcontroller. Lasts forever on a battery. That's the basic kit. This is the more advanced one from Avnet with more hardware. There we go. And there it is there. And this has got buttons. It's got stuff to plug stuff in. It's got sensors on there. It's got bits you can plug in. I don't even know what that socket at the back is. So you can plug it in, OLED screens, other bits and pieces as well. So yes, I've got temperature sensor, a few other bits and pieces on there. So these are kind of the 2 different variants of the Azure Sphere. Now, Azure Sphere is a whole secure hardware, but it is being used in professional industrial applications. In fact, Starbucks uses it. So if you ever go into Starbucks and they have their machines that make you coffee, those machines run Azure Sphere. So they are protected, they can manage maintenance of the machine, and they're secure. So the idea is nobody can hack Starbucks and change how to make a Frappuccino. The machines run using Azure Sphere. So this is not just a kind of a dev kit for you to play with. This is a real hardware device that is used in all manner of different scenarios. It's a great device. And I do apologize. I have the world's wobbliest desk. At some point, I need to knock my desk over and tighten the bolts underneath. It's very wobbly. It makes my camera wobbles a lot. So I do apologize. I need to get a more stable camera setup. So that's the Azure Sphere kit. Let's dive into this Learn module. Question for the audience, obviously. Have any of you ever played with Azure Sphere? I know, John, you said you're interested in Sphere. Has anyone ever played with Sphere before? Anyone actually got the hardware? If they have, let me know. Stick some comments in the chat. So let's actually start working through this Learn module. This we actually produced in partnership with the University of Oxford. So there is a course the University of Oxford runs all about AI and edge engineering. It's a long course, but that trains you up in how to be an AI edge engineer. So John not used it. Okay, today we're learning together. This is great. So this course covers a whole lot of stuff on AI and IoT on the edge. Lots of cool bits and pieces in this course. And as part of this course, they built some Microsoft Learn modules for us. So this Learn module is all part of that course. So let's wade through it. Let's see how far we get. So introduction. Building and running an application on microcontroller IoT devices can be challenging. These challenges could range from ease of development to securely capturing and transferring data to the server. With Azure Sphere, you can build IoT solutions that are secure by default, with the confidence that your device is protected, your application is protected, and your data is protected in transit. Now, that's kind of the interesting part about Azure Sphere, I think, is devices protected, applications protected, and data protected in transit. So when I've talked about IoT in the past, I've talked about how things like IoT Hub and IoT Central, our two services that run in the cloud for connecting your IoT device, these are secure in that only authenticated devices can connect. You have to have a certificate or a key to allow your device to connect. But apart from that, you don't get any other security in your IoT application. So I will write, for example, a Python app running under Raspberry Pi and then connect that to the cloud. And only that device can connect to the cloud because it's a secret key, but there's nothing stopping somebody SSHing into my Raspberry Pi if they know my password and then accessing my certificate and hacking my device. So Azure Sphere is all about the device is protected, the application is protected. Build applications with Visual Studio or Visual Studio Code on Windows and Linux. Now, those who know me know that I'm a Mac person, which is why I'm currently remote desktoped into my Windows box. So I've got a Surface Book here that my Sphere will be connected to. So I'm working on a Windows box. So it's only Windows and Linux you can use to develop Azure Sphere at the moment. I'm hoping Mac support is coming. Have asked for it. We'll see. So what is Azure Sphere? Azure Sphere is a comprehensive IoT security solution, including hardware, OS, and cloud components. So the idea is it's a combination of both the hardware, the operating system that runs on the device, and the cloud to make it secure. So you have certified chips. So we've got built-in Microsoft security on the chip to make sure this authenticated device, it's not just some kind of knockoff. It is an actual certified chip. We have our Sphere OS, and that runs on the non-real-time core on the device, and that's a secure operating system. And then we have a security service in the cloud that secures all the communication, looks for threats, pushes out updates to Azure Sphere OS onto your device, all that kind of stuff. And we got a whole lot of research papers on the 7 properties of highly secure devices. If you want to kind of read more on that, just get a short link put in the chat for you rather than have all that stuff there. But yes, you want to read. No, I don't want to get this free gift process. So we're kind of a whole process we've designed, a whole set of properties that are designed around making these devices secure. So this is the architecture of the chip. This is the thing that makes it secure. It's the fact it's based off 2 cores and a little security subsystem and a network and all these firewalls in between. So there's Cortex A7. This runs a Linux kernel. And so this can run kind of the Azure Sphere OS runs on this Cortex A7 chip. And then we have 2 of these ARM Cortex M4F chips. And they can run bare metal code, or you can run Azure RTOS or FreeRTOS. So you code up the ARM Cortex M4s as if it was any other microcontroller, and then you code up your real-time code for your Cortex A7 core. And the A7 core does all the network communication, does everything. So high-level applications running on the A7 Linux kernel are used for less time-sensitive tasks, such as establishing network connections, negotiating security, updating device state, communicating the real-time core, and sending telemetry messages to cloud gateways such as IoT Hub. So your real-time processing connects to your hardware, does all the hardware stuff, sends messages to the other core. That core can then send that up to the cloud. So you kind of got this nice separation in between. If somebody hacks your Cortex A7 code, it can't impact your real-time core code. If they hack your real-time core code, it doesn't talk to the network. So you kind of got these levels of protection built in. And then developer tools, Visual Studio Code. Cool. So this whole Learn module is focusing on a lab environment monitoring and control for sensitive microbiology experiments. So imagine you're a scientist in a microbiology lab responsible for storing samples from tests. You want to build a system that monitors the environment around the lab in real time. So monitoring pressure, temperature, humidity. Kind of some of the canonical IoT devices, we monitor pressure, temperature, humidity. This is the standard sensors a lot of folks use, but a great introduction here. So previously, these were recorded manually by lab assistants using sensors at regular intervals. Manual recordings is a tedious job and prone to error. And then if you have any issues with sensors or with the actual human error, it would invalidate the tests. So if we've got actual devices to do this, we've got a bit more control in our lab. We've got to maintain the room conditions. It's critical for our lab. We need to maintain the right conditions to get accurate results. Any wrong conditions get wrong results. So it's important in our lab to monitor pressure, temperature, humidity. So we proposed a new system that's got sensors in the lab, needs to be secure, as some experiments are commercially sensitive and expensive. So we need security against hackers, against commercial espionage, whatever. We need to make sure that we can prove that our lab sensors are secure. If somebody audits us to make sure we're secure, if we're doing highly sensitive work, we need to prove that we are. So these sensors will read air pressure, temperature, humidity, send it up the cloud, and then control an HVAC system. Temperature's too hot, cooling comes on, things like that. So we're going to build it on an IoT platform that's secure and protected from attack, and a system that can trigger alarm or alert messages when any of the defined parameters fall outside the expected range. So this is the kind of thing we want to build. We take an Azure Sphere device, range of sensors for temperature, pressure, and humidity. And then we're going to show everything on a dashboard, show some data on a dashboard to see what's coming out of our sensors. So this module, we're going to learn about IoT central applications, configure the device. Prerequisites, got my Sphere kits, got VS Code installed, got the bits and pieces. So let's go. Let's dive in. So our scenario, we want to manage the conditions in the lab. Now, we've got a bit of code here we can use. So we're not going to dive into actually writing the code. To build the code up for an Azure Sphere device, it's a lot of code. So we are just going to take existing code that's been built and run that on our devices, because we're learning about these devices and kind of how they work rather than diving too deep into the code. We're going to use an Azure Sphere board to act as a room environment monitor. So we'll deploy an application to the Sphere board, and that will transmit telemetry data to the cloud so we can monitor it. And then we're going to control our room from our board. And so we need to use our board and this learning path. Cool. Got that. I'm good with this. So supported devices. There's a few devices supported. Now I have got this one here, the Avnet Azure Sphere MT3620 Starter Kit Revision 2. It's very similar in look to the Revision 1, which has got connected to an OLED display, sensors, USB, status lights, light sensors, Sphere modules, a whole lot of different bits and pieces, buttons, buttons and LEDs, fairly standard IoT hardware. Got the Revision 2, the slightly newer version of the same thing. Then my Revision 2, okay. No, I've got a Revision 1, sorry, I've got a Revision 1, just look at that, I've got the Revision 1, because I've got the different connects on there. Revision 1. So if I actually look at mine, it's my OLED connectors, sensors, Grove connector, buttons, LEDs, expansion ports, all that. That's the one we're using. Could also use the MT3620 developer kit. This one doesn't have the sensors on it. So if you use this board for development, then it will just use simulated data for the temperature sensors. Oh, that's the development kit. Sorry, this is the mini dev pod. This is the other one I've got. That one there doesn't have the sensors. That mini one there. Now, what does it say here? Gpio Peripherals. In the labs, there's So the code that comes with this, there are several GPO peripheral variables declared for LEDs. So there's a number of different LEDs that we can use. So we have these Gpio peripherals. So the variables hold the pin number. So that's kind of okay. So this is a kind of code example of how we define pins. So this is a GPIO LED. We've got a pin, direction, a state, inverted, and a name. Okay, this is cool. So if you've ever done anything with Raspberry Pi where you've set a pin to be input or output, or Arduino, you set the pin to be input or output, this is what you got here. So the pin number, this is an output pin, so we're sending value 2. And then the initial state, we want it to be off. And then invert pin. So some pins, you send them a high value when you want them on. Some pins, high value when you want them off. It kind of depends very much on what you're connecting to. Some LEDs, it's a low value to be on, things like that. So we can choose with it. Okay, so there's kind of some code examples of how we set up a GPIO pin. Input for a button, for example, different pin, input. So okay, great. When we start looking for the code, this gives us an idea about the GPIO pins. Useful terms, hardware is the hardware, GPIO, input and output pins, peripheral types. Okay. Not much useful stuff there right now. I already know this stuff, but if you're working through this yourself, if you don't know what GPIO is or PWM, I2C, then we can read that to find more. So how do we set up Azure Sphere? Because Azure Sphere is secure. So how do I make this secure? How do I set it up? So before starting to prototype and develop Azure Sphere applications, you need to set up Azure Sphere on my PC. To learn how to install the Azure Sphere SDK, claim your device and set up Azure Sphere for application deployments. I have to claim my device. So make sure this is my device. That is interesting. So the steps to install it, I need to install the SDK. I need to claim my device by using the Azure Sphere tenant. So each device is claimed once, and after you claim your device, you can't move it to a different tenant. Claiming the device associates a unique immutable device ID with your Azure Sphere tenant. The Azure Sphere security service uses the device ID to identify and authenticate the device. Okay, this is kind of one of the interesting things about Azure Sphere then. So when you have a tenant, which is like an Active Directory account, so you'd have your company could have a tenant, or a division of your company could have a tenant, but it's basically your like account, as it were, that's shared between multiple people. And then each device can be claimed once and only once to a tenant. So I'm guessing it's kind of burnt into the hardware. Once you connect your device to a tenant, that's it. So in terms of playing, I guess, once you've connected this device to a tenant, you want to keep that tenant alive, because if not, this device becomes useless. If you delete the tenant, or you disassociate the device, deactivate it for whatever reason, this hardware becomes totally useless. You cannot use it anymore, which is a pain in the backside for developers. It'd be nice if there was a developer board you could reset the tenant, maybe. But certainly for secure computing, it's perfect. No one can nick your hardware and take it over if they can't reconnect you to a different service. So that's pretty cool. Then we need to configure Azure Sphere for network connection and update the device OS. As the device checks and receives OS updates and application updates from the Azure Sphere security service each time it boots. So that's pretty cool. So this device will then update its OS. So the OS runs on the A7 core, the non-real-time Linux core, and then we can update that. So configuration steps: install VS Code, done. Install the Azure Sphere SDK. Already done that, because you don't want to watch me sit here and twiddle my thumbs as that installs. Log into Sphere, create a tenant, set the default tenant, claim your device. Set up the Wi-Fi, update the OS, enable app development. So this is kind of the hardware configuration. So John, you're saying about using Raspberry Pi. This is the Azure Sphere equivalent of writing a new SD card and configuring the Wi-Fi connection, and then running sudo apt install. So that's the stuff we need to do to set that up. So the next unit is an exercise. For how long does MS commit to provide updates? That's a really good question, John. That is a very good question. I don't know what our commitment is on the hardware. I don't know where we actually define that. Because I mean, I know obviously we. I mean, I'm assuming it's going to be years because we support Azure Sphere. I don't know how old, because obviously there's older versions of the OS. I don't know how much we support them for. I don't know. I mean, Microsoft in general is very good at backwards compatibility. One of my favorite stories is back in the days of MS-DOS, there was kind of a small bug in the way the C, the way that memory allocations happened and deallocations. So you could deallocate a pointer, delete a pointer, and then the pointer would still work for a short while afterwards. And there was a bug in SimCity that deleted a pointer and then accessed it straight away. And so SimCity worked. But as soon as they ran it on Windows, where they fixed that issue, SimCity didn't work. And so Microsoft put a hack into Windows to say, if we're SimCity, do something slightly different. So if you're running SimCity, it recreates that bug for you, so SimCity doesn't crash. So we can be very, very good about backwards compatibility. So I don't know. I imagine a very long time. This is hardware. Once you've got the hardware, it's not like you can roll out new hardware every couple of years to the entirety of Starbucks. So that's a good question. I will take that question away, and then for next week's stream, I will try and see if I can get you the answer. That's a really good question, John. Because you don't want to have a piece of hardware and find a few years later it's not supported anymore when you've rolled it out to your industry. Okay, right. Let's jump on to the exercise. So the way, if you've not done Microsoft Learn before, they usually have a how to set up guide. You're welcome, John. You're welcome. I will hopefully get an answer for you by next week. So we have a guide how to set up Azure Sphere, and then we have an exercise. So this is what Learn does. We'll tell you what you have to do, and then we give you the hands-on steps, which is pretty cool. So Microsoft Learn is all about being hands-on. Okay, some little bit of troubleshooting at the start. If you have any issues, here's some things you might want to know. Shouldn't affect us, hopefully. So Windows 10, I'm running Windows 10. Need to install a few other bits and pieces. SDK, CMake and Ninja, VS Code, Visual Code, Azure Sphere extension. Okay. And Git. So there's a whole quick start here to set up a dev kit. So rather than just copy and paste everything to Learn, it's taken us to a quick start inside the Azure Sphere documentation to actually get everything set up. So what it says is plug it in, and you should see, and it should install the stuff. So let's plug it in. Let's put that one out of the way. Which way up do you go? You go this way up. We've got some lights flashing. The orange light is flashing. The orange light has stopped flashing. A green light is on. So I'm hoping if I go to Device Manager, Universal Serial Bus Controllers, Converter. Oh, I'm just seeing A, C, and D. Not seeing A, B, C, and D. So this says I should have C4. I wonder if it's just taking a bit of time to install some drivers. Okay, I wonder if it's actually showing anywhere in like Explorer's devices. It probably isn't. I'm not sure it's connected. Okay. Let's actually install this driver then. Virtual COM port driver. Click it down Windows 7 to Windows 11. Okay. So I actually played with this earlier with the other board, the smaller board, and that worked absolutely fine. So I don't know why this one hasn't. Oh. Don't know why this one hasn't picked up those 4. So okay, this one says. So I want to do one board right the way from the start. So while I'm looking at this, Alwyn asks, greeting from Bandung, Indonesia. Hello, thank you for joining me all the way from Indonesia. I have a question. Is it possible to somehow free the device after it was claimed and claimed it again later on? No, that is by design. You cannot do that. Once it's claimed to a tenant, that is it. You cannot claim it back. Pain in the backside for developers who are playing, but obviously that's just part of the security design is you cannot claim it back. It's once it's tied to a tenant, that's it. It's part of their secure design. So annoying for developers. It'd be nice there was a developer version where you could hit the reset button, but that's just part of the chip design. So you can't do that. So Windows, I guess universal 64-bit. Guess that's what I want. X64. How do I install this? Installation guide. You know what? Let's not muck about with that. Let's use the one that I did before. Let's use the smaller board. Plug that one in, and hopefully if I plug this one in, rather than muck about. Okay, now this is only saying ACD. This was working before. It came out with all 4. You know what? Let's just use the other board. Let's see how far we get. I mean, it's picked up something. The fact that it's showing these. So it's definitely picked it up. There it is. See if there's a driver's already installed. Okay. Oh well. Let's just assume that's working. If you previously used this board enabled RT app development, you'll see 3 converters instead of 4. This is normal, doesn't represent generic. Okay, teach me not to read the documentation, which makes me wonder then, I was told this was a new board. I wonder whether this one's already been claimed. I wonder whether this board that's been given has already been claimed. So if it has, I guess we'll find out. I guess I'll flip back to the other board. Okay, so install the Azure Sphere SDK. Already done that. You do not want to watch me install an SDK. Not interesting. In fact, if I do Azure Sphere show version, should happen in a second. There we go. I've got version 22 of the SDK. It needs CMake and Ninja. It's tools to kind of build C++ code. Already got those installed. Again, you don't want to be watching Jim installing stuff. And then there's the Azure Sphere extension in VS Code. So there's an extension in VS Code that allows you to do all the things. You can create new projects, run all the build commands, deploy, and debug. And kind of manages all the stuff for you, which is pretty cool. So I've already got that installed. Just go to the extension marketplace, install it from there. Okay, claim your device. So this is the bit where I can actually claim a device as mine. So let me just log in with Azure Sphere. There we go. Log in with that one. Logged into Azure Sphere. Nice. So if I go back here, logged in. Cool. That's me logged in. And then I need to register. If I've never logged in, I can register myself. I have logged in before, so I'm registered with the Azure Sphere service. But if you're not, steps here to register yourself. Now I need to choose a tenant. So your tenant is basically it's not your account, but it's kind of the larger organization that your Azure account belongs to. So if I list my tenants here, I have got one tenant. I've helpfully called it Jim's tenant, which I'm administrator. So I've created this Azure Sphere tenant. Once this is created, lots of people can join this tenant. I can add all my developers to it, but this is my one tenant. And I cannot, once I've got this tenant created and I assign a device to it, I cannot disconnect a device from this tenant. So this is my tenant that I've got set up. So this is something you'd want to have very well managed by your organization. You want to make sure there's security in place and no one, because if somebody deletes this tenant, that breaks every single device. Absolutely every single device is broken if somebody breaks that tenant. Okay, so let's claim the device. As it says, claiming a device is a one-time operation that you cannot undo, even if the device is sold or transferred to another person or organization. A device can only be claimed once. Once claimed, the device is permanently associated with the Azure Sphere tenant. So again, Alwyn, back to your question, it is permanently claimed. So you need to make sure you record the username used to claim the device and the tenant you claimed it into. So obviously these devices don't have any kind of unique identifier written on the device. If you're doing dev stuff, maybe stick a sticker on it or something, so you know which tenant or user it is. But you want to make sure that you track these devices. And I must have administrator or contributor permissions to claim a device in the tenant. So I'm an admin in the tenant. I can claim the device, but if I was adding other people to the tenant, they'd need to have certain rights to claim devices. So let's try claim this device. Now, I didn't buy this particular device off the shelf. The Azure Sphere team gave it to me. It was all packaged up nicely. So I'm hoping it hasn't been claimed yet. But let's try it. Okay, so now I claim it. I choose which tenant I want. So the default is to cancel because this is a one-time action. The default, if I just hit return, it won't just pick one tenant, it'll cancel it because we don't want to end up in a situation where I claim the wrong tenant. So 1. Okay, now it says my device's Azure Sphere OS version is deprecated. So there's an older version of the Azure Sphere OS on here. And then it's saying you're claiming the following tenant. Do I want to claim this device? You cannot change the Azure Sphere tenant this device is claimed to. So it really hammers home this, you cannot change it. Enter yes to continue, anything else to exit. I'm going to exit because it told me my OS was out of date. So I'm going to just run this command here. And that will update the OS on my device. Now, it says it may take up to 10 minutes. It shouldn't. Last time it only took a few seconds. So I'm hoping, fingers crossed, that this doesn't take very long. This is going to essentially wipe the OS. Currently, it's got a clean OS on there. There's no software installed. So on the Cortex 7 M7 core, the one that runs the Azure Sphere OS, there's none of my code on there. It's just got their code on there. It's just got the basic OS. So this is now updating that OS. So it's kind of like a clean install on this device. And the OS is 5.4 megabytes. That's actually flashing. So it's quite large. It's quite large, this Azure Sphere OS. But obviously you want to make sure it's got all that security code in there. So while that's running, let's just leave that going for a second. And let's look at the rest of the stuff we need to do. And we'll come back and claim this once that's finished. Git client, we've already got that installed. GNU ARM embedded toolchain. So I need to install that as well. So I've got the embedded toolchain. So this is the tooling that's needed to compile ARM code. So we'll just grab this version here. And that will work on the Cortex processor. Now, if I'm running a Linux, same instructions pretty much. Do the same thing, just a different set of tools to install. Now, we recommend to install Peacock, Visual Studio Code extension. Peacock allows you to color your Visual Studio Code. So it colors the border. So you can have different colored borders. And the reason this is really cool for Azure Sphere is the Azure Sphere board's got two cores. You have three cores. You have your Linux core, your M7 Linux core that runs your non-real-time code, the Azure Sphere OS, and then you have your real-time cores. And so what you can do is you can run one instance of Visual Studio debugging code that runs on the Linux core, the Azure Sphere OS core, and then one instance of Visual Studio Code running your real-time code on your real-time core. So if you want to debug, say, sending a message from hardware to the cloud, you would have a debugging session running on your real-time core that reads the hardware. That would then send that to the Azure Sphere core, and then you have another debug session to Azure Sphere core that connects to the cloud. So you have two instances of Visual Studio Code running. Peacock allows those instances of Visual Studio Code to be different colors, so you can quickly see that the red one is the real-time core, the blue one is the non-real-time core, something like that. So that's why I recommend Peacock. Ultramark asks, sorry if I already answered this, but if you can't switch tenants after claiming, the device basically can't be resold, repurposed ever again. Yes, correct. Once it's linked to a tenant, you cannot change the tenant that it is connected to. So if you link it to a tenant and the tenant gets deleted, you've just got some hardware that needs to be recycled. You cannot actually use this. You can't sell the hardware on. If Starbucks are using Azure Sphere in their coffee machines, if their coffee machine doesn't work, they can't go and sell it on to somewhere else because it just won't work. They'll have to take out the Azure Sphere chip and maybe replace that Sphere chip with the new one to sell it. So if you've got a large piece of hardware that's based off Azure Sphere that you want to sell, you would need to literally take out the Sphere chip and put in a brand new Sphere chip into that piece of hardware. But that's part of the security. It cannot be connected to somebody else. People cannot take your hardware and connect it to their servers. You don't want, yes, Ultramark, exactly. It's very secure. It's security through being a real pain in the backside. If I've got a piece of hardware connected to Azure Sphere, I cannot then route that from the manufacturer's servers to my servers. Also does mean something to think about if you are a large organization looking to buy an IoT company. If you buy an IoT company that uses Azure Sphere, you need to make sure you keep their cloud resources going because their hardware cannot be changed. It is vendor lock-in as well. So, it's not, once you've got this hardware, you can't change stuff. You're very limited. It's just the nature of that level of security. It cannot be changed, kind of burnt into the hardware. Security at a price, but that's what's needed if you want an ultra secure solution. Go away, OneDrive, I don't care. So that's Peacock, different colors, great for debugging the different things. And then we can run some code to delete any applications on there and restart them. So what's happened? Let's just check. Okay, so it's now finished recovering my device. It's pushed all the code on there. So let's just go back to the claiming step and just finish that off now that we've updated. So now if I run this, remember last time it complained about the OS being out of date. Now it's saying, right, claiming it to this tenant. The reason it didn't ask me is because I've already said I want to do this tenant last time I ran this before I did the update. So now it's saying, oh, you want to claim it to this device ID. Cannot change it. You cannot change this. It's not even enter wide to continue. It's yes. Actually have to type in yes. And once I do this, this is now mine forever. Let's say the Azure Sphere folks, they very kindly gave me this device. They ain't getting it back because there'd be no use to them anymore. I hope the person who gave it to me realizes they're not going to get it back. So that's now claimed. It is mine. It is linked to that tenant. In fact, I wonder if I can actually go to the Azure portal. Let me just sign into the Azure portal. I go in here. If I search for Azure Sphere, wonder if I can actually see it in the tenant here or anything. What is under Azure Active Directory? I've never actually looked for where it might be. Manage tenants. Here's my Azure Sphere tenant. Okay. So this is my Azure Sphere tenant that's created. I've got this tenant here. That's connected to me. And then I guess if I could probably switch directory, Azure Sphere. Okay, so I can switch to my Azure Sphere directory. This is all switched to my tenant. And I wonder where my Sphere devices are. I don't know if there's a description. Okay, I don't know. I'm not up on all that, on how that kind of stuff works. But yeah, so it's tied to my tenant. So let's just clear any apps. This kind of just wipes anything on there. There shouldn't be anything on there because it's a new board. And then let's just, yep, nothing to delete because it's just the OS. And then let's reboot the device. Then I need to turn on real-time core development. So this actually allows me to develop on the real-time core. Without this turned on, I wouldn't be able to push my own code to it. So I've actually got to do a configuration. I've got to do it in admin mode. Okay, let's just go here, terminal. More. Where's the run as administrator? There we go. So one thing Windows is really missing is sudo. I'm a Mac person, so I would be like, oh, sudo the thing. And yeah, Windows is missing sudo. So that's running, that's enabling real-time development. And then we've got a couple of learning paths here we can use. So let's just grab this code and grab some samples. So this is all the code is provided. So say this learning path is all about learning how to use it. We're not going to be diving too much in the actual code structure of that right now. It's just this is kind of how Sphere works. We're just going to just deploy existing code. So you know what, while that's going, let's just get another one going in here and clone the slave samples. Cool, let's clone that one. Let's clone that. My device is rebooting. So I kind of got myself ready now. I've now got ready to do some Azure Sphere development. So how do we connect it to IoT Central? This is kind of where we want to get to, is we want to connect from our device to Azure IoT Central. Now, IoT Central is a software as a service platform for IoT applications. And so this is IoT Central. It's all managed through a web portal. You create an application. You then tell it what devices you want. You tell it what data the device is going to send or receive. And then you can drag charts and graphs, all that kind of stuff for them. So you want to see temperature, you can literally say, here's a device. It's going to send a field called temperature, and I want a line chart for temperature. And then as long as your device connects, sends temperature, you will see a line chart of temperature. It's pretty cool. So that's what we need to set up an IoT Central application. IoT Central contains a whole lot of stuff. So IoT Hub is our underlying pipe for IoT data. It's like a message broker for IoT data. That sits below IoT Central. Device provisioning service manages automatic provisioning of devices, so permissions of devices. And we've got analytics on, so we can run jobs against our data that comes through, run analytics against it, and then run insights against our data and pull stuff out. So IoT Central got a whole lot of stuff built in, and we're going to set up an IoT Central application and allow that to connect to Azure Sphere. So again, think of that security thing. This is not just my device can connect to IoT Central. I actually have to allow it to connect at kind of the tenant level. I have to give it permission to connect to a device that's part of my tenant. Again, all part of that security angle. So going to IoT Central, build an application. So let's go in here. Go to apps. Now, one thing I will say is this learning path is very slightly out of date in that we have pushed a whole lot of UI updates to IoT Central. And the person who wrote this is busy updating it. We have the problem of the products moving quickly, and we've got to make sure we update all the images to look like it. So you might, and hopefully in the next couple of weeks, this learning path will be updated to look more like IoT Central. So go here, build an app, create a custom app. I will call it, not that, I'll call it Sphere app. Just create a free one, lasts for 7 days. So that will then go away and spin up the application. And this is the free application. IoT Central it's got a number of free tiers. The first one is a free trial, lasts for 7 days, and then just gets deleted automatically. So you know what? Let's not do a free one, because we'll be back in a week's time. We want it to still be here. So let's go to pricing and change it. We also have standard, so 3 levels of standard pricing, where you can do 400 messages a month, 5,000 or 30,000. So you can get a lot of messages per device come through, and you always get a free tier. So if I have 2 devices with 400 messages a month, that's completely free. Standard 2, most popular, 2 free devices, 3,000 messages a month. So I'm gonna pick one of those, choose my subscription, and save that. Let's upgrade that. That will last. Tweet something went wrong. Don't give me any of the something went wrong things. Okay, I'll upgrade this. Probably just need to refresh the page or something. Convert my trial, yes. Okay, I'll convert this before next week so that it lasts. But this is what he set up. And then I need to get a certificate. So what I need to get a certificate from my Azure Sphere tenant. So if I just go in here, download this. This will download my certificate from my tenant. Oh, I've already got one of those. Download that. This is a certificate that's linked to my tenant and allows me to connect something to my tenant. And then I can upload that certificate to IoT Central so that IoT Central can manage devices for my tenant. And so if I go in here, I go security, permissions, and then device connection groups. I can then create a new one of these. And I call this, what is it? What does it suggest I call it? It says I call it Azure Sphere, so I'll call it Azure Sphere. And so automatically connect devices in this group. So this is cool that any device that is provisioned with my certificate, which I get from my tenant, can connect to IoT Central automatically. So if I have a device, I can then add the certificate for my tenant. That certificate is baked into Azure Sphere. It'll appear on every single Sphere device, and that means every one of my Sphere devices with that certificate can connect to IoT Central and do everything. So I know that once I've kind of connected all these devices to my tenant, they will just work with IoT Central. They'll automatically create themselves as devices in IoT Central. It's pretty good. So I'll do that. Choose certificates. Save that. And then what it wants me to do, it wants me to upload my certificate. So I manage my certificate, upload it. So now I need to verify my certificate. So I get a verification code, which I copy. And then I need to use this verification code with my certificate to prove that the connection is valid. So I'm just gonna get my old one. Paste this here. And so this then says, give me a new certificate that's based off this verification code. So this goes to my Azure Sphere tenant and gets that. Do that. Give it a second. This gives me the verification certificate. I then click verify, choose my verification certificate. We are done. So now IoT Central is set up to connect to any device from any of my Azure Sphere devices. And we kind of got to a really nice point here where I have my Sphere device. It's connected just to me, just to my tenant, and I've got an IoT Central application that can talk to that tenant. And that's kind of a good place to stop for today. So next week, we will actually get the code running on the device and we'll get everything going, get everything working securely. We'll run code on the Azure Sphere OS core and on the real-time cores and get those two talking to each other and share everything working. But so far, been a very successful morning for me, or afternoon, evening, for wherever you are. And we've got some pretty cool stuff going. So thank you for joining me. Hope this was fun.
Thank you, Jim, and thank you everyone again for joining. If you have any feedback, we would love to hear from you. The event code is 15780. The link has been shared in the chat, so hope to see you guys next time. Thank you.
Awesome. Thank you, everyone. Thank you for joining.